In this video, we'll go over exercise F1-2B from the steel design examples according to the CSA S1614 codes, which is available for downloading at our website. Let's take a look at the description of the exercise. Basically, this is a W-shaped flexural member design in the strong axis bending and is braced at third points in the section. We need to verify the factor moment resistance of this 460 by 74 section, which is the same selected in the previous exercise F1-1A. And we will apply the requirements of the code. Now this section is 10 meters long and it has a distributed dead load of 6.6 kilonewtons over meters and a live load of 10.9 kilonewtons over meters. And as I mentioned, is bracing at both ends and third points. Now let's take a look at the exercise in S-frame. Here's our beam model. So I'm using a section property 460 by 74. And you can, if you right click, you can access the parameters of this section. For material, using material number 1 steel. The supports is pinned at both ends. If we move to the loads window, we can see I have two load cases defined, dead load and live load. And if I display these load cases, it's 6.6 in the negative z direction for the dead load and a live load of 10.9. If we go to edit load combinations, I can see I have defined one load combination for this case. So I'll proceed with the analysis. Go analyze just for the load combination. And after checking on some of the results, I can go to STIL. The first thing I can see is if I go to the effective length factors and right click, see that it's braced at 1/3 at the bottom of top flange. Click OK. I'm ready to run a quick code check for the load combination I have. I can see my utilization ratio values, and if I right click, access the code details, I can go to view and zoom to have a better view of my results. And here they are. I can see some differences when calculated some values like omega-2 for the bending stability check. I can see there's some difference in these values, thus the mu value as well, between the hand calculations and STIL. And this is due mainly to the way Mmax, Ma, Mb, and Mc are determined by hand calculations and using STIL. Via hand calculations, by following the design code, it uses the moments obtained for each embrace segment. For example, the span length divided by 3 for this example. While STIL uses the moments obtained for the entire length of the member. And except of the help system on this topic discusses this in more detail. And if you check your hand calculations, we get a value of MR 468 kilonewtons per meter, while in STIL we get a value of 479 kilonewtons per meter. Now, and again, the difference in the values of MR between the hand calculation and STIL is due mainly to the differences in the values of omega-2 and Mu, the elastic critical buckling moment, that we already discussed. Thank you for watching, and for more tutorials and videos, please subscribe to our YouTube channel.